Hey everyone, in this video we'll be solving quadratic word problems that involve age and integer. Our first example, the square of a number decreased by twice the number is 63. Find all possible numbers. So we'll start with our let statement. So we'll let x be equal to the number. So the square of a number, so x squared, decreased by twice the number, so minus 2x, is 63, so equals 63. We have a quadratic equation. In order to solve, we need it equal to 0. So we'll subtract 63 from both sides. So we have x squared minus 2x minus 63 equals 0. And now we try to factor. So we need a factor pair of negative 63 that adds to negative 2. So that's negative 9 and positive 7. So either x minus 9 equals 0 or x plus 7 equals 0. So that means either x equals 9 or x equals negative 7. So the possible numbers are negative 7 or 9. If we write out a solution set, we'd have negative 7, 9. Next up, when 55 is subtracted from the square of a number, the result is 6 times the number. Find all positive numbers that make this true. So we'll let x be equal to a positive number. So 55 is subtracted from the square of a number. So square the number, subtract 55, and that's equal to 6 times the number. So 6 times x. We have a quadratic, we need it equal to 0, so we'll subtract 6x from both sides. So we have x squared minus 6x minus 55 equals 0. So we factor. So we need a factor pair of negative 55 that adds to negative 6. So that's going to be negative 11 and positive 5. So our factors are x minus 11 and x plus 5. So that means either x minus 11 equals 0 or x plus 5 equals 0. That means x equals 11 or x equals negative 5. Now the question asks us to find all positive numbers. So for that reason, only x equals 11 is a valid solution. Okay, so we reject the negative 5. A number to the third power is equal to 4 times the number. Find all possible numbers. So again, our let statement is let x be equal to the number. So a number to the third power, so x to the third, is equal to 4 times the number. So here we don't have a quadratic, we actually have a cubic because it's to the third. We're going to solve this by factoring, so we need it equal to 0. So we have x cubed minus 4x equals 0. We can take out a greatest common factor of x, and then we're left with x squared minus 4 equals 0. X squared minus 4 can be factored using the difference of two squares. And now we have 3 factors whose product is 0. So by the zero product property, either x equals 0, x minus 2 equals 0, or x plus 2 equals 0. So here we'd have x equals 2, here we'd have x equals negative 2. The question asks us to find all possible numbers. So our solution set would be negative 2, 0, or 2. Moving right along, James and Bob have ages that are consecutive integers. The product of their ages is 132. If James is younger, find each of their ages. Okay, so we're going to let x be equal to James's age. And then x plus 1 is equal to Bob's age. Right? Consecutive integers, x and x plus 1. So their product, so x times x plus 1 is equal to 132. We'll distribute out x. So x squared plus x equals 132. We have a quadratic equation, which we need to set equal to 0. So x squared plus x minus 132 equals 0. So now we need to factor this. So we need a factor pair of negative 132 that adds to positive 1. So it's going to be x plus 12 and x minus 11. So that means that either x plus 12 equals 0 or x minus 11 equals 0. So either x equals negative 12 or x equals 11. Now, in the context of this problem, we're talking about ages. So it does not make sense to have a negative age. So that means James is 11 years old and Bob is 12 years old. Perfect. Next up, the product of two consecutive even integers is 10 less than 9 times the smaller integer. Find the integers. Okay, so we'll let x be the first even integer. So then x plus 2 is the second even integer. So it says the product of two consecutive even integers, so x times x plus 2, is, so equals, 10 less than 9 times the smaller integer. So 9 times the smaller integer, which is x, and then 10 less than that, so minus 10. We'll start by distributing the x, so x squared plus 2x equals 9x minus 10. Now we have a quadratic equation, so it needs to be equal to 0. So x squared minus 7x plus 10 equals 0. So now we factor. So we need a factor pair of positive 10 that adds to negative 7. So negative 5 and negative 2. So our factors are x minus 5 and x minus 2 equals 0. By the zero product property, either x minus 5 equals 0 or x minus 2 equals 0. So either x equals 5 or x equals 2. So find the integers. Well, we're talking about an even integer. So because we're talking about an even integer, x equals 5 does not make sense here. That's an odd number. So then the integers are 2 and 4. Those are the consecutive even integers that have the property as described in the word problem. The product of two consecutive odd integers is 1 less than 5 times their sum. Find the integers. Okay, so we'll let x be equal to the first odd integer, and then x plus 2 is the second odd integer. So the product of two consecutive odd integers, so x times x plus 2 is, so equals, 1 less than 5 times their sum. So 5 times their sum, which is x plus 2, and then we're going to take away 1. So we'll start by distributing here. So we have x squared plus 2x equals 5 times 2x plus 2 minus 1. We'll distribute the 5, so x squared plus 2x equals 10x plus 10 minus 1, which gives us x squared plus 2x equals 10x plus 9. We have a quadratic equation. We need to set it equal to 0. So subtract 10x, we get x squared minus 8x, and then we'll subtract 9, so minus 9 equals 0. Factoring, we have x minus 9 times x plus 1 equals 0. So that means either x minus 9 equals 0 or x plus 1 equals 0. So that means either x equals 9 or x equals negative 1. Now what does this mean? Well, this means there's two sets of integers that would make this problem true. Okay, so we have either 9 and 11 or negative 1 and positive 1. Okay, so we have two sets of odd integers whose product is 1 less than 5 times their sum. Okay, and you can check these by plugging them in. If the squares of two consecutive integers are added together, the result is 841. Find the integers. So we'll let x be the first integer, and then x plus 1 is the second integer. So the squares of two consecutive integers are added together. Well, the square of the first integer is x squared. The square of the second integer is x plus 1 squared. And the sum of the squares is 841. Now as a reminder, x plus 1 squared, that's x plus 1 times x plus 1. So we have x squared plus x plus 1 equals 841. Combining our like terms, 2x squared plus 2x plus 1 equals 841. Quadratic, so we need it equal to 0. So 2x squared plus 2x minus 840 equals 0. Common factor of 2. So we'll take out a GCF of 2. We're left with x squared plus x minus 420 equals 0. Okay, so we need factors of 420 that add up to 1. Okay, so let's go to the calculator. Let's see what we can come up with. So let's see, 420 divided by 10. 42, okay, that's not going to work. Let's go 420 divided by 20, let's say. That's 21. Well, that's perfect. One of these has to be negative, right? Because we're multiplying to negative 420. So 21 and 20 will make 21 positive and 20 negative. So that means either 2 equals 0, x plus 21 equals 0, or x minus 20 equals 0 for the product to be 0. So that means either x equals negative 21 or x equals 20. Now, 2 doesn't equal 0, and we're just dealing with consecutive integers, so both of these are valid answers. We're going to have two sets of consecutive integers. So our first set would be 20 and 21. Those two integers have this property, or negative 21 and negative 20. So there are the solutions. And that actually kind of makes sense, that we have 20 and 21 and negative 21 and negative 20, because when we square these values, it doesn't matter if they're positive or negative. So there is a little bit of logic to this solution. Amy's and Jane's ages are consecutive even integers where Amy is younger. The sum of twice the square of Amy's age and 5 times Jane's age is 112. Find Jane's age. Okay, we'll start with a good let statement. So consecutive even integers, Amy is younger. So we'll let x be Amy's age. And then consecutive even, so x plus 2 is Jane's age. So the sum of twice the square of Amy's age and 5 times Jane's age. Okay, so twice the square of Amy's age. So the square of Amy's age is x squared. Twice it is 2x squared. And we're adding to that 5 times Jane's age. So 5 times x plus 2. And if we do that, we're going to get 112. Okay, so we'll distribute out the 5. So 2x squared plus 5x plus 10 equals 112. Plus 10 equals 112. Okay, so subtract 112 from both sides, so it's equal to 0. So minus 102 equals 0. So we'll factor this one by grouping. So 2 times negative 102 is negative 204. So we need a factor pair of negative 204 that adds to positive 5. So let's go to the calculator here. Okay, so we have 204. So let's see, divided by 4. That's 51. That's not going to work. Let's say 204 divided by 16. Nope, that doesn't go nicely. 204 divided by 17. So that's 12. So 17 times 12. Well, one of them has to be negative because we're multiplying to negative 204. So we can get positive 5. So we found the factor pair, 12 and 17. So we're going to go negative 12 times positive 17. So we'll rewrite this as 2x squared minus 12x plus 17x minus 102 equals 0. We'll group the first two together, second two together. So GCF of the first two is 2x. We're left with x minus 6. And then GCF of the next two is 17. We're left with x minus 6 equals 0. Take out a greatest common factor of x minus 6. We're left with 2x plus 17 equals 0. So either x minus 6 equals 0 or 2x plus 17 equals 0. So either x equals 6 or x equals negative 17 over 2. Now we're finding Jane's age, and x is Amy's age, so doesn't make sense for x to be negative. So x equals 6, but we have to find Jane's age. So Jane is 6 plus 2, so she's 8 years old. Find 3 consecutive odd integers such that the square of the largest integer added to the product of the other two is 64. So our let statement, so we'll let x be the first odd integer. X plus 2 is the second odd integer. And then x plus 4 is the third odd integer. Okay, so we have our let statement. So the square of the largest integer, so that's x plus 4 squared, added to the product of the other two, so that's x times x plus 2, is 64. So again, x plus 4 squared is x plus 4 times x plus 4. So we have x squared plus 4x plus 4x plus 16. Distributing the x, we have x squared plus 2x equals 64. Combining our like terms, we have 2x squared plus 10x plus 16 equals 64. Now we have a quadratic, so it needs to be equal to 0. So 2x squared plus 10x, and then we have 16 minus 64. So 16 minus 64, negative 48 equals 0. We can take out a greatest common factor of 2. That leaves us with x squared plus 5x minus 24 equals 0. So we need a factor pair of negative 24 that adds to positive 5. So that's a to negative 3. So we have x plus 8 times x minus 3 equals 0. So we have either 2 equals 0, x plus 8 equals 0, or x minus 3 equals 0. So we have x equals negative 8, or x equals 3. Okay, so 2 doesn't equal 0. Now we're talking about odd integers based on our let statement. So negative 8 is even. That gets rejected. So x equals 3 is the only valid solution. And we're looking for all 3 odd integers. So 3, 5, and 7 are the consecutive odd integers such that this is true. So there are the word problems that deal with age and integer. Okay, a lot of consecutive integers again, consecutive integers, consecutive odd, and consecutive even. So with a well-defined let statement and reading the problem carefully, translating it mathematically to an equation, from there, we're simplifying and solving a quadratic. Here, we didn't have to use the quadratic formula in any of these examples. All of these were factorable, which makes sense for a lot of age and integer problems. Okay, but again, the focus is getting that equation correct, translating the word problem to the equation correctly. That's the key. And that's what you need to practice as much as possible, and then solve to make sure that you know how to finish the problem off correctly. So, now it's your turn. Get as many problems as you can done. Click the Amazon link down below for my algebra workbook so you can practice on your own. Give the video a like, and before you go, click that subscribe button so you can see more videos just like this. Thanks for watching.